enjoying my lectures. So in this session we'll be discussing the section formula, that is the internal and external division, and we shall also discuss the various applications, that is the questions based on section formula. So let's begin. Okay, so the next concept that we have is the section formula. Again, this is also interesting and it's quite easy also. Let A, B and C be three collinear points in space having position vectors A, B, R. We are taking this A, B and C. These are three collinear points in space having position vectors. This is A, this is B and this is R, right? Let AC by CB is N by M. This is N by M, AC by CB it's given. Or M into AC, take it here, M into AC becomes N into CB. M into AC vector is N into CB vector because the vectors are in the same direction. Then OA plus AC is OC. Just see here, OA, this plus AC is OC. Quite obvious, we have already discussed these concepts. If this is this vector, this is OA vector plus AC vector, resultant would be the OC vector. So OA plus AC is OC, which implies that AC becomes OC minus OA. AC becomes OC minus OA, and OC you can see is R, minus OA is A. So we have AC is R vector minus A vector. Similarly, R plus CB is B vector. Again, this vector plus this vector, resultant would be this vector. So we have R plus CB vector is B vector. Therefore, CB becomes vector B minus vector R. So we have AC is vector R minus vector A and CB is vector B minus vector R. And now using this equation, I had M into AC is N into CB. So AC is vector R minus vector A and CB is vector B minus vector R. So from this, okay, I'll erase this. So from this equation what I have is M into vector R minus vector A is N into vector B minus vector R, or M into vector R, or you can write vector R into M plus N, take this term on this side, gives me N into B vector plus M into A vector. Or you can write R vector becomes MA plus NB by M plus N, and this is the required formula. So what you need to note here is just that if you have a case like this, when this is A vector, this is R, this is B vector, and it's given that this is some kind of ratio is given for these two sides, then in that case your vector R would be MA plus NB by M plus N. A and B are vectors, right? So just you need to keep in mind this formula. Let us solve some questions based on this. You will be able to understand it quite easily. So the first example that I have is, find the position vector of a point R which divides the lines joining two points P and Q in the ratio 2:1 internally and externally. Okay. So it's given P is I plus 2J minus K, and Q is given minus I plus J plus K. And further it is given that we need to find out the position vector of point R which divides these two lines joining these 2 points. In fact, we should have drawn in this way. I need to find out position vector of R which divides it in the ratio 2:1. So this is my M is to N, and I need to find out this vector R. How do you proceed? How do you proceed? As we have just not discussed in the last question, that just apply the formula for R, that will be 2 into this coordinate, that is 2 into minus I plus J plus K, plus 1 into I, 2 into this plus 1 into this divided by sum of ratio, that is 2 plus 1. So we have I plus 2j minus k and divided by 2 plus 1. So this will be equal to, I have for I minus 2 plus 1. Then for j, the coordinate that I have, coefficients that I have is 2 plus 2. Then for k, 2 minus 1. Divided by we have 3. So this becomes minus I plus 4j plus k divided by 3. Right? So this is for internal division. Similarly, what about the external division? For external division, again the formula would remain same, but we'll have here a minus sign. So R would be equal to 2 into minus I plus j plus k minus 1 into I plus 2j minus k, and divided by, we'll have, this is 1 into this term, divided by 2 minus 1. So for external division, we have 2 into minus I plus j plus k minus 1 into I plus 2j minus k by 2 minus 1. So this gives me minus 3I minus k. This is the required answer. So see, section formula is quite simple and even its application is also simple. The next question that I have is, find the position vector of the centroid of the triangle ABC when position vector of the vertices A, B and C are vectors ABC respectively. So what is it saying? I have a triangle of this form A, B, C. Then this is given that the position vector of vertices A, B and C are A, B and C respectively. So this is what I have. Now suppose a position vector of the centroid of triangle we are required to find. Let me assume that G is the centroid. So we know that centroid divides this into ratio 2:1. It divides the median AD in the ratio 2:1. So what am I saying? Let G be the centroid of the triangle. Centroid of triangle ABC, right? And we know that centroid divides median AD in ratio 2:1. Therefore, the position vector, this implies the position vector of midpoint D of side BC. Now, what about the midpoint? First of all, this won't be, this implies this would be also. Now see, AD is the median, so it divides this side into equal parts, and therefore the position vector of this point would be B plus C by 2, because vertex B is B and vertex C is C vector. So the position vector of D would be B plus C by 2, and therefore position vector of midpoint D of side BC is B plus C by 2, right? Also, position vector of G. What about G? Now we will be applying the section formula, because see, this is dividing this median in the ratio 2:1, and we already have the position vectors of A and D. So what I get is 2 into B plus C by 2 plus 1 into A divided by sum of m plus n, that is 2 plus 1. This gives me 2 gets cancelled, and I have A plus B plus C by 3. So see, it was given, we were required to find out the position vector of centroid of the triangle ABC, that is G. and the concept involved was of section formula. So until and unless you know this property that the centroid divides the median in the ratio 2:1, you won't be able to apply the section formula, even if you know it, you know the formula very well, right? So in mathematics, all the concepts are quite interrelated. You need to know each and every concept, plus you need to know where are you supposed to apply a particular concept. So just practice a good number of questions on section formula also. It is quite simple. So I hope you must have understood the section formula. It is quite simple, and so it can fetch you some easy scores.